So let's talk about the theory of significant figures. Your chemistry teacher should have gone over this, but I'll do a quick review. Significant figures are directly related to how well the instrument could make a measurement. And that really comes down to what kind of precision does the instrument have. So, let's pretend I have 3 very poorly drawn rulers on the board. Let's say this is from 0 to 10 centimeters. Let's say that these are the only markings on this ruler. We know 0 centimeters, we know 10 centimeters. We know no other marks or divisions in between, none. And let's say something is this long, from 0 to here. And I'm going to ask you, well, what's its measurement? How long is it? You got to guess. There's no telling really what the actual length is. You know it's between 0 and 10 centimeters. That's it. That's all you know. So if you guess, it's kind of nearly in the middle. And maybe I'm going to guess 4 centimeters. Maybe someone's like, nah, it's a little more towards the middle. I'm going to guess 5 centimeters. Maybe somebody's like, it's in between that. I'm going to call it 4.5 centimeters. Well, in science, this isn't allowed. You're not allowed to do that. Why? You get one digit, one placement in a number for a guessed value. You can guess 4, you can guess 5, but you can't guess anything more than one digit of what we call unknown value. What this means is that this measurement is one significant figure. Yeah, it's significant. I'll show you. Hold on. Let's take this ruler and I gotta divide this up a little better. Let's take that same object that we had before, and we're going to put it here. And now in this ruler, we have more divisions in the ruler that are printed. So this ruler and this ruler are different. This one has a little more precision. And now with this new ruler, we're going to ask you to measure the same object. Well, now we can clearly tell that this object is definitely between 4 and 5 centimeters long. So it's a little more useful than this ruler. So we know that it's definitely at least 4 centimeters, but not quite 5 centimeters. So we know that this object is 4 point something centimeters long. That's a known digit, it's a known value, or known placement in this measurement. And so the question is, well, where is it between the 4 and the 5? So I'm looking at it close, and it's a little tough to tell from where you are. I don't feel like moving the camera just yet, but it's close to the halfway point. I'm going to say it's not quite there. It's close, so I'm going to call this 4.4 centimeters. Now you might have called this 4.4 point. Come on, Tapper. might have called it 4.5 centimeters. And both are within reason. But the thing here is we have a placement which is known. It's definite. It's at least 4 centimeters long. And then we have another placement in each of these measurements which is guessed. Because in measurement you're allowed one guessed placement in the value. That means that these numbers or measurements, each of these have two significant figures. Significant figures are all of the known placements plus one additional guessed placement in a value, in a measurement. So let's take this ruler and let's make it even let's make a third ruler that's even more precise. I'm not going to draw the whole ruler. I'm just going to draw between 4 and 5. And let's pretend that this particular ruler has the divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's say that this is right here. Now, you can't really see that all that well, so let's bring you in. Okay. And notice that I put that arrow after 4.4, but before 4.5. That's important. So, in this scenario, on this ruler, this object from 0 to here would be 4.4 something. You have to guess that last value. And this measuring scale allows us to zoom in even more. This measurement's more significant because we were able to get a more accurate picture, a more precise view of the value. So here, again, I might guess 4.45 centimeters. This is 3 significant figures. It's 3 significant figures because there are 2 placements that are known. We know them to be definite. We know that the instrument allows us to know that, plus 1 additional guessed placement. That's the theory behind significant figures. Now, how we interpret measurements when they're given to us, we'll talk about next.